All right, section 3.5, reference models. We're going to see now how we use different models in order to be able to create basically a theory of networking. Now, why are these important? These are important because it allows you to do better problem solving and troubleshooting. Cisco is very, very heavy on this model and understanding how this model works in the real world. So again, if you're doing this chapter and you're reading 3.5, have Wireshark pulled up. Play around with Wireshark and see how Wireshark interacts with this theory. We should be able to see the theory of the reference models applied in the real world Wireshark environment. So again, don't be overwhelmed when you see all the packets being coming through. You can stop at any point in time. But do something that you know happens, like in a lab where you're pinging a web page. Well, ping is an ICMP packet. Well, try pinging other things and see what happens. This is a great way for you to take the theory that you're learning about networking and seeing it applied in a real world environment and how changing a couple of different things can really impact what happens. Now, let's start off with, if you notice in the earlier section, I kind of waffled. I got my layers all jumbled. And the reason why is I live in a 7-layer model world. So on the left-handed side, we see the OSI model. I really love the OSI model. I eat, sleep, and drink the OSI model. I do my troubleshooting with the OSI model. I reference everything through the OSI model. So the OSI model, the bottom layer there is the physical layer. Physical. Okay, so hopefully I'll get off YouTube for that. Okay, all right, so physical layer is layer 1. That is the layer that actually transmits the data. That's going to be your raw binary bits, whether it's wireless, fiber optic, copper, coaxial, whatever the physical media is, that's the physical layer. By the way, that's next chapter. We're going to learn about the physical layer. Chapter 4 is the data link layer. No, excuse me. Chapter 5 is data link layer. We're going to spend an entire chapter talking about data link. Layer 2. Layer 3 is the network. We get a couple of chapters for layer 3. Layer 3 is really our bread and butter in the networking world. We do a whole lot with IP addressing and IPv6. We're going to do subnetting and all sorts of binary conversion. It's a blast. So think about that. That's network layer. Transport layer is where we do ports. And if you notice, the network, well, let's look at the model here real quick. You can see, you can see here that the data link and physical layer that were in the OSI model are a single layer in the TCP IP model. The network layer in the OSI model becomes the internet layer in the TCP IP model. Transport is transport. And then we take all three of these, like application, presentation, session, and we jam them all into application in the TCP IP model. Cisco will be asking you questions on both their quizzes and on the CCNA certification. They're going to expect you to know OSI model versus TCP model and how the two, how the two interact with each other, or what they're same and likewise, or alike or different. So if they're going to say, IP addressing is in what layer? Well, it's layer 3 in the TCP IP model, layer 2 of the TCP IP model, layer 3 of the OSI model. Now, again, the benefit of this layered model is we can really divorce ourselves of the whole conglomerate. If I just want to work on a single slither information, you can. Like, let's take the Ethernet layer, for instance. Ethernet is a relatively new protocol in the networking world. In fact, if you have any Tim Ferriss fans, Tim Ferriss actually interviewed the man who helped create the Ethernet protocol. And what's interesting is he talks a little bit about the dynamics of creating the Ethernet protocol and how they got it adopted. So Ethernet protocol is, if you have an RJ45 cable like this one, some people will call this an Ethernet cable. That's because the Ethernet protocol. It's technically an RJ45 cable, or it's a twisted pair cable, RJ45N, Ethernet cable. I call it that way too sometimes. All right. But the nice thing is you can develop new protocols independent of everything else, which is very beneficial. Now, this model, again, we eat, sleep, and drink the OSI model in the Cisco environment. And you're going to have to know what happens at each one of these layers. So layer 1, physical, as I just said, That's where we're doing the raw binary. The ones and zeros being sent somewhere else, that's physical layer. Data link, this describes the method of exchanging data from frames. If you remember, we talked about the frame, PDU, the protocol data unit frame. So that's where we actually put the Ethernet header on it. It has all the information, and it has a cyclical checksum at the end of it to make sure everything's correct. Network is layer 3. This provides our IP addressing. So IPv4 or IPv6 all happen there at layer 3. Layer 4, this is our ports for where we initiate communication. So define services to segments, transfer, and reassemble the data for individual communication. So that's how we actually make with that. Session provides like how we break stuff up and make sure that we have communications. Presentation is your image files, whether those be GIF or movie files or even just a picture, JPEG. All those are done in presentation. The application layer would be HTTP, the same thing we talked about in the earlier session, all those different applications that get involved. And likewise, TCP, we just talked about this, I'm not going to hit it again. Basically, it's a little more consolidated with the TCP IP reference model. So what we're going to look at now is in section 3.6, we're going to look at data encapsulation. We're going to see how do we take these suites and actually use them in a networking world in order to make communications happen. And so we're going to follow some packets along their path.